My name is Bernie Thompson, and I'm here today at the AAPEX show with Pete Meyer of Motor Age magazine. I would like to introduce you to the Bullseye leak detection system. The Bullseye leak detection system was developed due to the problems that auto techs like yourself have when using the modern leak detection. If I have an evap system, many times we can't find these type of leaks. Additionally, air conditioning systems, again, are really tough leaks to find. What the Bullseye does that's very unique is we put CO2 into the sealed system, and the CO2 in the sealed system, where it leaks out, will be found with an electronic leak detector. The electronic leak detector gives me the area that this is happening, and then we have a specialized foam that has a color change. So let's take a look at how this will work. First, we would have the CO2 and a high pressure regulator, and then we're going to feed this to a low pressure regulator for an evap system. We'll charge the system to 25 inches of water. The 25 inches of water is under all standards, so we're safe. We never want to overpressurize a system. Anytime we overpressurize it, we can create damage to that system, so we always want to charge less than 1 psi. Once we've charged the system up, we can check to see if the system is leaking with the gauge. As we can see, the gauge is on the yellow to orange line. That means that we have somewhere about a 15 thousandths leak in the system currently. To make sure that this is happening, we want to also do a pressure decay test. Let me explain. When we first flow the CO2 in, we're looking for a flow rate. The flow going in is what we're reading. But flow can be confused, so what we really want to do is we want to be able to check decay. Pressure decay is where I have a sealed system and I watch if we have a leak, and that leak is dropping. So what we're going to do is we're going to go ahead and shut the CO2 off. That shuttles a valve inside the mechanism. Once we shuttle the valve in the mechanism, we can start to watch the decay. The decay will be the needle dropping. Any decay rate more than 1 inch in 1 minute, well, you guys are going to have to find the leak now. And that's going to be really hard in some instances. In many times, we smoke these systems, but we've all got to understand that smoke does not come out small holes. Actually, I misstated that. Smoke is coming out the hole, but it's optically not visible. A cloud in the sky is a vapor. And if the vapor is condensed, I can see it, so it distorts light. But when I have 100% humidity in the day, that also has a vapor, but I can't see the cloud. Smoke will work very much the same way. If I don't have enough smoke in an area to change or distort light, I obviously can't see the smoke. So in small holes, we don't have enough smoke coming out to see with your naked eye. So what we want to do is do a different system. Rather than smoke, we're going to look for the CO2. So we can see that we've dropped quite a bit within the gauge. We're going to go ahead and we're going to start this back up. Whenever you work on any system, whether you're using the Bullseye or your own system, there's two main things that you need to know. The first thing you need to know is the leak present right now while you're working on the car? The second thing that you need to know is you need to make sure how big the leak is. If I have a big leak or a small leak, this is going to make a big difference in how I'm going to approach the repair of the car. Now we know that we have a very small leak. It's about a 15 thousandths leak. By the decay rate and the flow meter both indicate that. So we got a smaller leak. This is going to need to be handled a little bit differently. Large leaks have large amounts of CO2 coming out, so I can move probes way faster. So what we're going to do now is we're going to take the CO2 probe and we're going to go around the area. I have a 15 thousandths leak on my test stand, and we would see that if we just go around the bottle cap, and we would want to go totally around, and you're going to use this very much like you would do an air conditioning system. We all have done those air conditioning systems, and we know that those sensors don't work very good. This is not an air conditioning sensor where we're looking for a hydrocarbon blend for refrigerant. We're going to be looking for CO2, and the detector is specific to that. So the hole is right where the black dot is, so the idea is when I pass over the hole, we clearly see that we have CO2 in leaking. Now the one thing about the CO2 leak is I might be able to know that the area it is. Many of these systems with evap have lines and hoses that are very close to each other on these valves. So the idea is, where is exactly the leak? That's what I need to do. So in order to show you exactly where that leak is, where there's multiple connections, we developed a specialized leak detector solution called Bullseye Leak Detector Foam. This has a color change that interacts with the CO2 leaking and changes, so it goes from pink to yellow. Let me demonstrate. We're going to shake the can so we have a foam, and then we're going to spray it on the bottle. And we can see that we've changed the foam at the leak site to yellow. Now this leak foam is designed to where it will change color on a very, very small hole. So this is also going to do air conditioning systems. Now air conditioning systems are really unique because of the size of the leak. These leaks are 2/10,000ths to 1/10,000ths. To give you a better idea, that's one with like 10 zeros and a number. The area is very small. That means that these leaks are even harder to find. When we put CO2 in, we gain advantages. When we have a refrigerant base, the hydrocarbon is very, very large. These very large hydrocarbons are an issue because I'm trying to go through a very small hole that's basically a scientific notation. It's really hard to even get your head around how small these holes are. Let's think about it. I'm losing 8 to 9 grams a year. Now, if I lose 9 grams a year, I'm going to have to fix it because I'm going to have decreased performance out of my air conditioning system. So the idea is if I had 9 grams, 10 grams, we'll give you a bigger leak. How much is leaking each day? Well, that's a very small percentage. But what I really want you to start to think about is how much is actually leaking during your inspection. You're in contact with this leak site for what, 5 or 10 seconds? When nothing is coming out, that makes it very hard to find these type of leaks. So what you're going to need to do is take the refrigerant out. I don't want this huge molecule in there. I'm going to charge the system with system-safe CO2. CO2 is a very small molecule. Now there's smaller atoms. We have helium and we have hydrogen. Both of these are a smaller atom, but we don't have a smaller molecule. A molecule is very small, being CO2, and the CO2 will leak out these sites very easily. We also are going to get another gain. Refrigerant, when we have refrigerant in an air conditioning system, that refrigerant is temperature based. So if I have a 70-degree day, on the low side, I can only have 70 pounds of pressure. If I have a 90-degree day, I have 90 pounds. If I have an 80-degree day, I'll have 80 pounds. So I never have a high pressure presence to push this large molecule out this very small hole. When we recover the refrigerant out of the system and we put CO2 in, now I can put this at a much higher pressure. So now I can have 160 pounds of pressure. I can double my pressure with a much smaller molecule. Now I have a lot more volume coming out of the leak site. So now we can find these super small leaks every time. And this system is going to also work on all kinds of systems. Your tires, head gaskets. Why would you have a head gasket? Well, when you burn a hydrocarbon-based gasoline and hydrocarbons and oxygen combust, we end up with water and CO2. The CO2 is going to go into the cooling system. So if I just take the radiator cap without the engine running and hold the probe over the radiator cap, if the system detects CO2, you have an impaired gasket. And we don't even need system integrity on these cooling systems as well. So if your water pump or your radiator burst, right now you would tell your customer, I'm going to have to put the radiator in. This might be $700, and then I'm going to tell you if the head gasket is blown. This is doing a disjustice to your customer. What you really need to do is use the Bullseye system. If there's no water in the system, remove the upper radiator hose from the thermostat housing, take the probe connector and hold the probe right at the top of the neck. If it goes off, you have a damaged head gasket or a liner, or there's some way the combustion gases are getting into the cooling system. This system really works, and it will work in your shop as it works in thousands of other people's shop. Thank you for your time.